Hello everyone, welcome back. In the previous video, we discussed about ADC peripheral in Holtek microcontrollers. In this video, we are going to quickly cover how to configure the periodic type timer module in PWM mode using the PTP pin for PWM output. Overview about PTM. PTM is a versatile timer module that can operate in different modes like compare match, timer event counter, PWM output. We'll focus on PWM mode, which is used to generate PWM signal. PTP pin for PWM. In PWM mode, the PTP pin is the dedicated output pin for PWM. You'll need to make sure the pin is properly configured in the port control register before using it. Into the overview of today's code. In the main function, we have first configured the PTP pin as output by configuring PAS17 and PAS16 bits. Here we make sure the pins are set correctly for the PWM signal. Next, we configure the watchdog timer. This timer is used to reset the system if something goes wrong, but in this case we are disabling it or setting it to safe start. Now let us get into the main part of the code. Configuring the PTM for PWM mode. Here we set the PTM clock to run at Fsys by 4, meaning the clock speed will be divided by 4. The PTM will be set to PWM mode and the output will be inverted. We can set this operation in the PTM C0 and PTM C1 registers. You can refer to the data sheet for more information. Now let's calculate how to set up a 2 kHz PWM signal on HD66F3195. We know the system clock is 8 MHz and prescaler is Fsys by 4. The timer clock becomes 2 MHz. The formula for PWM frequency is FPWM is equal to Ftimer divided by period. To get a 2 kHz PWM frequency, we calculate the period as period equal to 2 MHz divided by 2 kHz, which gives a timer value of 1000. So the period is set to 1000 counts. Now setting the period in PTMR register. PTMR-PL, which is nothing but the low byte of PTMR register, is stored with 0xE8, and the PTMR-PH, which is the high byte of PTMR register, with 0x03. This gives us a period of 1000 counts, resulting in a 2 kHz PWM signal. To configure 50% duty cycle, we need to divide the original timer count, that is 1000, by 2, which gives us a value of 500 in decimal. If we convert that value into hexadecimal, it is gonna be 1F4, which we are loading into PTM-AL and PTM-AH registers. Now we simply enable the PTM to start the PWM output by configuring PT on bit to high. Finally, we need to keep the system running without triggering a reset. To do that, we clear the watchdog timer in an infinite loop. To summarize this code, to configure the HD663195 microcontroller to generate a 2 kHz PWM signal with a 50% duty cycle on the PTP pin, we also disable the watchdog timer to keep things running smoothly. Once configured, you will get a PWM output from PTP pin, which can be used for motor control or dimming LEDs. Moving on to the practical demonstration. Once the E-Link is been connected to our microcontroller, a window will pop up in the IDE saying that connected to E-Link Pro 2 for HT8 OCDES. You click on OK. Build the code. As you can see, build has been successful. To view the PWM output, we are gonna use a hardware tool called Logic Analyzer. We're gonna monitor the PWM signal in a web-based application called Logic. Now let us run the code. We'll run the logic. As you can see, we are getting the PWM signal of frequency 2 kHz and duty 50%. That's how you configure the 2 kHz PWM signal with a 50% duty cycle on HT66F3195. Hope this video was helpful. For more such videos on how to use Holtek microcontrollers and its peripherals, stay tuned to our channel.